So first of all, we're going to simplify this, so we got to factor anything that we can factor. And I always do top first, then the bottom. So let's do the top. Start by asking yourself, and this is going to go back to what I said at the end of last semester, if you are asked to factor something, you always start by finding what they have in common. So, looking at the top, I have 3x minus 6. What do those have in common? Raise your hand if you know. What do they have in common? Chris? They're both multiples of 3. So, take out a 3. When you do this, it means you are dividing each term by 3. So 3x becomes 1x. You don't need to write the 1. I'm just writing it for the example. Minus 6 becomes minus 2. That's it for the numerator. Now we're going to factor the denominator. But, looking here, do they have anything in common? I don't see anything. What is this, though? This is something we have seen a lot. Very, very recently. Colin? That is a quadratic. So if I am going to factor this, what method am I going to use? X method. I am going to factor this. So I am using the X method. So, set it up. Multiplying to make negative 6, adding to make 1. The two numbers that I need are what?
5. Wait,
I heard a couple people say it. Negative 2 and positive 3. Now, we're not looking for a final answer right now. We're looking for the factors. So this is going back to actually making the binomials. Remember, from what we did last semester, this becomes 1x minus 2. This becomes 1x minus 3. I'm sorry, plus 3. Because it's positive. Okay, we factored everything we can factor. We factored the top, we factored the bottom. Now, we look for common factors. We look for things that we can cancel. Raise your hand if you see something that is exactly the same on the top as it is on the bottom, because that's when I know that I can cancel things. Dylan. I said exactly the same. Very, very specific about being exactly the same. Taylor. Right, there's a 1x minus 2 here and a 1x minus 2 there. They are exactly the same. Remember in the last example I said you need the entire polynomial, not just the pieces. So here's what I have left. On the top I have the number 3. On the bottom I have the polynomial x plus 3. This part's really important. This 3 on top is a constant, just the number 3. This denominator is a polynomial, x plus 3. Because this is a constant and this is a polynomial, that 3 does not cancel this 3. If there was a random other 3 just sitting in front of all this with parentheses, then sure, that's a constant, they can cancel. But these do not cancel each other. This 3 on the bottom is part of this polynomial. So that is our final simplified form. But we now have to find the excluded values. The more you do this, you won't have to write these separately. You'll actually be able to do them in your head. If I'm going to find my excluded values, I have to take what I factored on the bottom, x minus 2 and x plus 3, and I have to solve them for 0. We did this last chapter, zero product property. Solve them separately. I want to know what makes x minus 2 equal 0. I want to know what makes x plus 3 equal 0. This one would be a 2. This one would be a negative 3. This is very similar to the shortcut we saw when we were solving quadratics by factoring. And you could use that here. But sometimes what you have on the bottom, you didn't use X method to get that, so sometimes you will have to write this out. So our final answer then, we'll just go back up here. We factored and we simplified 3 over x plus 3, but x cannot be 2, x cannot be negative 3. Altogether, that is our final answer. Oh, sorry, cannot equal.